actually gets to live here now in beautiful Reno. So I'm happy to introduce Dr. Dr. Paul. And I'll let him take it away.
Thank you, Mary. Can you all hear me reasonably well? All right, great. So as you know, I'm here with Susan Liebman, who is a professor at the University of Nevada, Reno School of Medicine, and I want to thank her personally for inviting me to moderate this Fireside Chat as we discuss her book, The Dressmaker's Mirror. And Sue, I'm not going to give away, if you want to call it the punchline, about why the book is called Dressmaker's Mirror. I think you're going to have to read the book to find out. You know, I read the book, and my impression is there are really two storylines that run through the book. One is a personal and family memoir, and then the other is a discussion about genetics and how they impacted how genetics impacted your family, and it impacted it very dramatically. So maybe we should first start with a discussion about your upbringing. I found it really fascinating because you got involved in science at an early age, and at a time when women generally weren't getting involved in science. And one of the accomplishments as a native New Yorker myself was that you were a Westinghouse, was it scholar? Which I remember hearing about this. This was a major feat for high school kids to get that honorific. And it really launched your career. So I know we're getting a little bit of feedback, Ellen. I don't know if we can fix that.
Dr. Paul, can you put the mic closer to your mouth? Because it's harder to hear back here.
I can hold it.
I mean, Paul, sorry.
All right, how's that?
Oh, that is better.
So I was saying that Sue got involved in the sciences at a very early age, and just thought we would begin by you telling the audience how you got so involved in science, really in junior high school and high school.
So there were two things. One, my parents had decided that a girl could do anything, and they weren't in science. I remember my mom started giving me, in addition to my Nancy Drew books and books on on Israel, these weird books appeared on bees, and I didn't understand. And she said, well, that's because I read in the New York Times that girls don't like math and science, and I thought if I showed you this, you could give that a chance. And I thought, wow, that's amazing. Why wouldn't girls like math or science? And then the second major thing I share with Susie was that I attended this wonderful high school, neighborhood high school, and well, I did love math and science, as it turned out. So I took all the math and science courses, and one of the courses I took was called AP Zoology. And this was really a make-believe course for a fantastic teacher. I understand now that he liked to be called Mr. Lawrence, because his PhD was in English. So he didn't really like it when you called him Dr. Lawrence. And on the cover of the book, you can actually see a picture of me in Washington, D.C., with the other 40 finalists that year. So what Mr. Lawrence did was he taught zoology, but if you entered in the Westinghouse Science Talent Search, you didn't have to take the final. So we all entered, and my year there were 2 winners. There was a year when there were 5 winners from the public Brooklyn High School, whereas Stuyvesant and Brooklyn Polytech and schools that had entrance exams, didn't do as well as we did. So it was all Mr. Lawrence that really inspired me, and Susie backs me up on that. So, and then there was my sister, who went to school in the Boston area, and she was very social and into boys, and I was into study, and she was very worried about me. She said, you know what, I have this friend at MIT, because she knew all the boys in Boston, and they actually have girls. You should apply to MIT. And so I did, and that's what happened.
So going to MIT as a woman was still unusual at that time, and you followed that with a visit to the Harvard campus and got a PhD. I'm trying to remember if you got a PhD at MIT or at Harvard, or it was University of Rochester. Right, so you went MIT, Harvard, University of Rochester, and kept going. Were there barriers that you were aware of at that time? Because we talk a lot today about potential barriers for women, and they still exist. So this was some time ago. What sort of barriers did you face?
I really have to say I didn't face barriers that I'm aware of. Well, there's one I can talk about, but basically MIT bent over backwards to welcome us. It was a wonderful place to go to school for a woman. The dormitory was wonderful and welcoming. I mean, there may have been things, but on balance, it was a great place. I left Harvard because Alan didn't get a job in Boston, and he got a job at Xerox. And so I ended up there, and that turned out, Rochester was a great place for me. I had a great advisor. The only thing with women was when I looked for a job, and I got a job at the University of Illinois, they were kind enough to negotiate and wait a year for my husband to get a job. But the salary they gave me was from the year before, so with inflation, I had a very low salary, and I never asked them about it until one day, 20 years later, 25 years later, Alan said, you can look up your salary, it's a state university, and I had the lowest salary, but I had the highest grants. So I went in and I said, what's this? And they said, oh, okay, and they doubled my salary. I mean, so that may have been, and I didn't quite have the furniture that some of the guys had, but it was, there was nothing set for women who had children for pregnancy when I started at University of Illinois at Chicago. There was absolutely no provision. But my colleagues were amazing. Elliot Spies said, oh, I'm teaching genetics. I'll teach your class and my class. And then the next year, I taught his class and my class. And, they wanted me to succeed. They really did. And they helped me in every possible way. So.
One thing that we've done in the last couple of years is to address pay inequity with our female scientists. I feel very good about that. There are demographic or chronologic challenges that females face today in laboratory science. I mean, you're in your 30s when you're really working to get tenure, and you're also in your 30s when you're trying to raise a family, have a family, and raise a family. So we're acutely aware of that. We actually set up a fund that we are intending to direct seed funding to a number of our female faculty to help support them during that period of time. It's great to hear that it was relatively seamless for you. Before we get too involved on the scientific front, let's just go back to the personal front. You grew up in a Jewish home in Brooklyn, so tell us about the Yiddishkeit there and the atmosphere you grew up in.
Well, my grandmother lived with us, and she lit Shabbat candles every night. She made a Shabbat meal every night. I won't say I loved the food, but she cooked, and I remember it. Actually, it's interesting. Someone wrote me an email who read the book, and she remembered that terrible chicken fricassee with a horrible neck inside it that you would find. But my grandma was very involved in the local shul. I went to that shul, and I was in the boys' bar mitzvah class, but I, of course, was not bar mitzvah. And then they switched me to the local reform shul, where they promised they would bar mitzvah me, but they reneged, and I didn't get bar mitzvah till 7 years ago, right here in this shul. But we followed the holidays at home. My father had a strong upbringing. I think when my mother's father died, she lost religion. She had been so involved in it that she just totally lost religion. But my father cared about it. I was not somebody who could believe in God on high in the throne, and I sort of told him that, and he said, don't tell anybody you're an atheist. That's not, you're not. You believe in the goodness of people, and that stood me well my whole life. I do believe in the goodness of people. I do believe in many things besides that on high thing. So that's the way I was brought up with. Jewish stuff. But throughout the book, you can see I think of things through a Jewish lens. A lot of that came later, my years here as well, and the Jewish learning I did both at Sinai and Emmanuel. So.
Wonderful. So a lot of your early work seems to have been focused on prions. I want to tell the audience a little bit about that sort of mysterious, neither a virus nor a bacteria nor a fungus called a prion.
So actually, that came mid-career. So I'm an old lady. So I had a whole career before prions were discovered. But it turned out, and I was working on something called translation, where you read the genetic code, and then it's like a sentence, and you hit a stop codon, and you're supposed to stop. And I was studying the things that helped you read that stop codon. And it turned out one of them was very weird. It didn't act like a normal gene. And I was studying it. Me and 2 or 3 other of my famous best friends in the world were studying it. Nobody cared about it. It was bizarre. And then someone, a colleague at NIH, had this great hypothesis that that weird thing was a prion, the same as the mad cow disease, which was, and it turned out it is. And it helped us prove the real prion hypothesis. So that was serendipity. A lot of science is like that. But so what is a prion? The thing with the mad cow disease is that you don't get sick from a bacteria. You don't get sick from a virus. You get sick from your own protein. So how does that happen? Now I've got to put this down. No, I'll just... This is your protein, and the same protein is all over your cell, and everything's fine. It does its job, it's got its fingers. But every now and then, certain proteins fold wrong. And when they do, they make all their neighbors fold wrong too. And now they don't work anymore. They're all aggregated and folded wrong. So that can cause mad cow disease for that prion protein. But in yeast, it made the thing that recognized the ends of genes not work. And now there may be actual functional prions. It's also involved in diseases like Alzheimer's and ALS, and that's what we're studying now, where it's not a prion, but it does change the conformation, and it is infectious.
And very infectious.
Depending on the prion, it can be very infectious. Yeah, and not even destroyed by autoclave, which is very upsetting.
So you're in the field of, essentially in the field of genetics, reading DNA and studying it, getting grants in it. And in the background, no one's connected the dots of things that have happened in your family until maybe later. You know, reading your book, there are these periods of great tragedy. There was a 4-year-old who dies. There's your father who dies suddenly. So both children and adults. And then, of course, your niece. You provide a family tree, which is very helpful as you read the book, because I would go back and refer to the family tree to understand who's who. Perhaps one of the most tragic photographs, certainly in the book, but just in general, is the photograph of your niece who's pregnant with her husband the day before she dies, suddenly.
You want to grab that and pass it around? Or just hold?
And I don't know if that was the actual prompt for you to really dig deep to try to find out what connected all these tragic events in the family?
Absolutely. I didn't see the others' events as tragic until my niece died. So the day my niece died, the day my niece dies was a great tragedy. The autopsy came back and said, we don't know why, it wasn't murder. But the New York City coroner's office took her heart and sent it away, and 2 weeks later they came back and said it was dilated cardiomyopathy. And I knew that word because my sister in her 50s had been diagnosed with dilated cardiomyopathy. And even a yeast geneticist can figure this out. I realized all of a sudden I was in trouble. And I wanted to find out. I mean, my niece was 6 months pregnant when she died. My daughter, at the same time, was 3 months pregnant. I was terrified. Yes, it was a terrible tragedy for me when I learned what death was, when my father died at 66. But I understand that when you're 33 and your father dies at 66, it is tragic, but this is life. And it took me 10 years to realize that, but I did eventually get it, that this is the best you get in life. But when my niece died, it brought all of this back, and I had to figure out what was going on. The story about my uncle dying when he was 4 was, of course, the mirror fell on him and killed him. Oh my God. That was something that went through the family for many, many years. My father told me that story, and my uncle told me that story.
So maybe what we can do is talk a little bit about cardiomyopathy and what it is. That's an area that I know a lot about. It's my clinical practice was focused on it. My research was partly focused on it. Broadly speaking, cardiomyopathy means a disease of the heart muscle. And broadly speaking, there are two types. There's something called ischemic cardiomyopathy, which is more prevalent. It's what happens if you have a heart attack or multiple heart attacks and the heart starts to fail. The heart attacks have caused scar to develop in the heart. The heart generally enlarges at that point, and a whole slew of problems can occur as a result of that. But there are also individuals who have no blockages in the heart whatsoever and have a primary heart muscle disease. It is very heterogeneous. There are multiple different causes. Years ago, when I was just starting out, people would often characterize non-ischemic cardiomyopathy or dilated cardiomyopathy, the heart being enlarged, as, a virus attacked your heart. This was the common lore. It turns out to be completely untrue.
And that's what they told my sister and one of the 3 people in my study.
Right, and
who still believes it.
And I believe, and it's still unfortunately communicated to patients sometimes because it's a belief that, well, there's no other explanation, so it must be a virus. That's what physicians do, right? I can't explain it, it's a virus. Because you can't see it, you can't touch it, and it's just an easy explanation. It turns out to be wrong. I would say in 99% plus cases. There are mostly, there's a genetic underpinning for the vast majority of cases of dilated cardiomyopathy. And this foundation of knowledge has exploded in the last 20 or 25 years. And Sue, when you were in your journey looking for causes, I don't know if you're aware, but you've interacted with 2 experts in the field, Ray Hirschberger, who I knew and still know. He was at the University of Oregon, then University of Miami, and now at Ohio State. And he's a cardiovascular geneticist. And Elizabeth McNally, we trained together in Boston, who is now at Northwestern, has been there for a long time. So tell us a little bit about how you went about looking for the underlying cause and how you connected the dots to all this.
Well, Ray Hirschberger my sister lived in Florida, and so she was looking for a genetic cardiologist, and she drove down from where she was to Miami, and she interacted with him, and Jill Siegfried, I think, was the genetic counselor. But there were only a few genes that were known to cause dilated cardiomyopathy at the time, and he tested her, and she didn't have any of them. I was, as we've talked, a yeast geneticist, and I used to know a lot of people in yeast genetics in Chicago, and we had a monthly club where we would go and share stories about yeast genetics. And I, of course, talked about my family. These were my friends, and one of them, Steve Meredith, said to me, Steve Krohn's wife, Elizabeth McNally, Steve Krohn was a yeast geneticist, is a great genetic cardiologist. You should go see her. And the good thing that I did was I went to her as a patient. So I have a colleague who went to her as a colleague and didn't get the same response. So going as a patient was a very good thing. She took care of me. She told me that my children and I needed to act as if we had this mutation, because there was one, and there was a chance we had it. We had to get tested all the time, and that she would keep testing for the mutation, which she did. She sent my sister's DNA all these different places, and they all said no, no, no. And finally she said, some years down the line, it doesn't cost $1 billion anymore to sequence the human genome. And I've got 5 patients, and I can't figure out what's causing their genetic cardiomyopathy. Your sister's one of them. It costs $50,000, and I have a grant. I'm going to do it. And she did. She sequenced my sister's genome. She found the mutation. She didn't tell me. She wasn't sure. She published it. She moved. I moved. I didn't hear about it till somewhat later, but eventually I got the news. So that's how I got to know her.
And I think that fund of knowledge is expanding all the time as more and more of these defects are recognized. Because getting genetically tested is a lot, as you suggest, a lot less expensive today, but also the panels are a lot broader than they used to be. And there's a whole range of abnormalities, most of them connected to, in some way, heart muscle cells or the anchoring of heart muscle cells to each other. And when that goes awry, there's often slippage, and the heart enlarges, and the contraction starts to fail. It's part of the challenge here is that there isn't targeted treatment for each of these genetic abnormalities. The treatment really is more conventional treatment towards heart failure. However, the ability to screen family members who are at risk, I think, is a really important step forward. So why don't you tell us something about the actual defect that was finally detected?
It's a mutation in the filamin C gene, which is a muscle component in muscles and also in the heart. I really don't, you could tell more about the details of how that works. All I know was that when we found it, I did a literature search, and there were other people who had this mutation. As a matter of fact, they had the exact same mutation, which surprised me no end, to the nucleotide. And in one of the descriptions, it was clear that what I had been doing for the decade to protect me and my children, which is getting echocardiograms, was not sufficient. You could have a perfect echocardiogram and drop dead. So you needed to have MRI and other kinds of screens, because there's 2 things that this defect can cause. One is dilated cardiomyopathy, which could be treated with some kind of pills, but the other is arrhythmia that can be not noticed and then cause death. So that's what I know about these. I did, in my searches in the literature, then start corresponding. And it's amazing how these people corresponded with me. I tell them I used to say, oh, I used to study yeast. Oh, yes, yeast told us this. We know about the whole genome because of yeast. So they treated me like a colleague. And one of them said, I have these 2 families that have, out of my 50 families that we studied from people all over the world, that have your exact mutation. They're Ashkenazi Jews. Are you an Ashkenazi Jew? And this was a guy in Israel, Michael Arad. And so then I looked up, there was this irritable bowel disease database. And 1 in 800 Ashkenazi Jews has our specific mutation. But I don't want you to understand, lots of other people have mutations in this gene. And there's lots of other genes that cause this same thing. It's nothing special about being Ashkenazi. But this particular mutation was around forever. My hope that it was new to my sister, no. And that I didn't have to worry about, no, it wasn't. It's been around for hundreds of years. So.
These genetic defects, though, they have, not everybody gets them. Maybe you can give us a quick elevator talk as to why not everybody in your family has it. And even if you have it, there's something called mixed penetrance, which means that you may have the defect, but it may not be fully expressed in you. And that's probably due to the influence of other genes that you have, including potentially mutations in those other genes, some of which can be productive, some of which can exacerbate the defect. At UNR Med, we have 2 research teams working on muscular dystrophy. That's another example where people always think about the skeletal muscle, the arms, the legs, the muscles there, but a significant proportion of those patients also develop dilated cardiomyopathy. So it really runs the gamut. There's still individuals who will have a diagnosis of dilated cardiomyopathy. They'll get genetically tested, and nothing comes up. So it's not all solved yet. If you take a look at all patients with heart failure, dilated cardiomyopathy is probably less than 50% of cases. In fact, it's probably closer to, I don't know, 20% of cases. When you're practicing in a university setting, in a referral center where I practiced for many years in Boston and St. Louis predominantly, you get a skewed view of it because if you're 20 years old and you've been diagnosed with a heart problem, guess what? You're sent to the university hospital for evaluation and further management. So my panel of patients were predominantly dilated cardiomyopathy as a diagnosis. You know, one thing that struck me in reading the book, I'll get to the question in a second, is, you know, here you are as a patient with Dr. McNally, here you are as a concerned family member, and then there's also the scientist in you. And that's sometimes difficult to bridge the two. Are you going to be the scientist in figuring this out? Are you going to be the family member and a patient? So how did you navigate that? Because you're obviously so invested in what happened in your family, and yet you have this fund of knowledge that I don't have, and probably most people in this room don't have.
I think it was pretty seamless for me. I was Dr. McNally's patient, but I knew her husband, and we were friends, and she treated me, you know, like somebody who understood. When she would tell me, I thought I had this, it's in an intron. She didn't, you know, she understood the level at which she could talk with me about it. One of the things you mentioned, this word penetrance, and that's one of my pet peeves that I do want to talk about. So one of the things that Dr. McNally told me was that my children, as well as I, should be getting echocardiograms every year till we knew if we were at risk. And wherever he is, was not so thrilled for me to tell our children that they might drop dead, and maybe, you know, and maybe that would inhibit them from having babies, which we were very anxious to have them do at that time. Actually, my daughter already was pregnant. So we came up with a deal, and the deal was I could tell them the whole story, everything I wanted, once. I couldn't ask them next year, did you do it? And the year after that, did you do it? That was it. Once they were adults, tell them. It was a fair deal. My daughter got tested until the day I told her she didn't need to be tested anymore. When I told my son 10 years later, he said, tested? Tested? Oh, I went to my doctor, and my doctor said, does your mother have a heart problem with dilated cardiomyopathy? And he said, no. So my doctor said that I couldn't inherit it because you didn't have it. The doctor didn't know about penetrance, that I could have the mutation and hand it on to my son, and he could get very sick, young, die right then, and I might never show it. So this is, you know, there's not a lot of things doctors need to know about genetics, but this is one of them.
So would you, you know, given the experience that you had, what sort of advice would you have? I mean, physicians are really pretty lousy at taking, I'll be honest, taking good family history. And there are also, you know, obviously stories within a family that may or may not be accurate about what happened to Uncle Leo or what have you. Well, what sort of recommendation would you have? Because this is something that we discuss a lot clinically. If you have a patient with dilated cardiomyopathy, you know, how much counseling should the family undergo and genetic testing and so forth? I think if I spoke to Dr. McNally, she would give a definitive yes. If I talked to Ray Hirschberger, he would say a definitive yes. But that's not widely practiced right now.
And that's part of the reason for the book, is to get people to understand the gravity of the situation, to see it from a personal point of view, and to understand that trying to put this off, trying to forget it, trying to bury your head under the sand is not going to make it go away. The idea that your 36-year-old beautiful daughter, you saw her picture, might have to have an implanted defibrillator might seem too horrifying to consider. And you don't want to get her tested because, God forbid, this beautiful woman would have a little scratch on her. Well, wait till she drops dead. Then you see what really should have happened. And that's the whole purpose of the book, to get you to understand. The other thing is the idea of penetrance, the idea that just because you have the mutation doesn't mean that you're going to get sick. It's just like having high blood pressure. It's something you have to take care of. Just to put it in perspective of, this is a tool we have. And I don't think there's anybody who showed up here. Yes, yeah, KJ can, her husband will talk about not Jewish Nevada, Healthy Nevada. It is one of the few places where we do offer genetic screening. There's 11 genes that are, I think it's 11, maybe it's a few more now, that are the first tier genes. I myself would, and that's better than almost every state in the country. So I complain at them, but we're doing great. But I want to see 81 genes tested. So the American College of General Genomics has declared, they have a committees, they fight over it, they discuss, genes get put on the list, taken off the list. But meanwhile, this year, there's 81 genes that they call actionable. That is, if you have a mutation in one of these genes that cause cancer, heart disease, and various other things, you can do something about it. We don't want to know about Alzheimer's or ALS. You can't do anything about it. These are genes that they fight that you can do something about. They have agreed that if you get your genome sequenced for some reason, like you have cancer and you have your genome sequenced, and you find my gene, FLNC, a mutation, you should tell the patient. But they don't agree that people should get screened for it. And I don't really get it. So the best I can understand is they tell me, we don't have enough doctors, we don't have enough follow-through. If you've already been screened, then you already have a doctor, you know how to do it. To me, these are things to fix, and they're certainly not things that in this room should inhibit you from getting a screen. The other thing that is something to be concerned about, and you know, if there's nobody in your family who has the disease that you've been told you get from this mutation, it's possible that in your genetic background it might be different, and you might have to look at that carefully. So there may be some differences, where in my family this gene causes death all the time. In an African-American family, maybe it won't. So that's something we have to be a little concerned about. But in the case of heart disease, so you get a few extra echocardiograms. If it's a cancer and you're going to have to, go through operations, I think you want to be a little more concerned if no one in your family shows this. So given that drawback still, I really, and it's not recommended by anybody else but me, but I recommend getting screened for the 81 genes that are actionable. And there's a postcard there for Picture Genetics that'll do it for you for $295. They provide the doctor.
So this is an area of great controversy. I'm not sure that I would actually advocate to get widely screened unless there is a compelling reason within your family. There are actionable genetic mutations, but I don't know if I'd say the vast majority, but many are not actionable at this point. And it does create great tension in the family and great concern in the family. The other thing is there are implications for insurance. The good news is you cannot be denied health insurance if you have a genetic defect, but you sure can be denied for life insurance, for disability insurance, and so forth. So if you have a young person, I would advocate, and even if there's a compelling reason to get genetically tested, I would make sure that that young person gets life insurance, gets disability insurance, and then waits a while before they get genetically tested. So that's
and can we change those laws too?
Well, when commercial testing was first available, you could lose health insurance on the basis of the testing. So at least we've gotten that far. The other thing is there are times when the results come back and they're confusing. There's something called a VUS, or variant of uncertain or unclear significance, which means it's not a typical finding for that particular gene, but it's also nothing that's been described as being associated with a particular condition or disease. And so it's sort of in between. And how you manage that information is very unclear. Some would advocate, well, get tested again in 5 years or 10 years, because that variant of unclear significance might be now clear as to what it may or may not be associated with. It may in fact be just a variant of normal, but it can also be associated with an underlying condition. The one thing that this country needs more of, well, there are many things, but one for sure in medicine are genetic counselors. There are not enough of them. We struggle with that at Renown. We're looking for genetic counselors because more and more of this testing is going to get done, and you really just can't say to a patient, oh, you have this genetic mutation, come see me in 6 months and, for a checkup. I mean, it's not fair to the patient, and it's not good medical care. And so I can tell you that there are training programs, master's degree programs in genetic counseling. Those graduates, we don't have a program right now at UNR, those graduates from a variety of different institutions, University of Cincinnati is well known for its program, get scooped up immediately. They're in high demand.
They're actually, I mean, on LinkedIn, they can't find a job right now. I told you this before. There's a lot, it changed on a dime.
Well, we're looking. So
I'm going to give you some more of those names. I got 100 people. They're all graduating and they can't find jobs. Part of the reason is state. You have to be in the right state. You can't be a genetic counselor on the phone, and you know the laws have got to be changed.
Maybe we should open it up for some question and answer.
In your book, Karen's brother was tested. What were his results, Jeffrey?
Yeah. Okay. Jeffrey's negative. We're a blessed family. Thank you.
Mara?
So my question is, when you get married, there's a bunch of, in your Ashkenazi families, like there are genetic tests that you go through from Canavans to Tay-Sachs to all that. Is there something that's being investigated right now that if you have a carrier on one side versus another, like are you at higher risk if you have both or that kind of thing?
So I should have mentioned that the mutations I'm talking about are dominant, and so that is not an effect. But I do have cards there from J-Screen. The ones I have there are about cancer screens, but they are innovators in carrier screening they started with Ashkenazi, but now they have carrier screening for everybody, and they do a wonderful job. KJ?
So I have a lot of comments. Particularly, thank you for talking about the ethical implications for young people getting tested and life insurance and disability, because it is the same situation, for example, with BRCA gene, in Ashkenazi Jews, and I sat on a big panel in which there were a bunch of advocates, and we still didn't get it done. But what I wanted to say is actually, in answer to Mara's question, in Israel, where there's much more extensive genetic testing.
Can people hear you? You can hear. Okay.
I'm a New York Jew.
Are we all?
Really? Yeah. Okay. So Susie, can you hear you? Yeah, you can hear? Susie, can you hear?
Okay. So thank you. So in Israel, where there are a lot more, a wider spectrum of things that are tested prior to marriage at anyone's request. There are major centers that do it. You can't just walk into your PCP's office because it's nationalized healthcare and ask for it. But there are major university centers that are doing it. And because of advocacy by parents of children with certain types of dilated cardiomyopathy in certain groups, such as Ashkenazis, but also in the Christian Arab population in northern Israel, where I was a physician, there was a lot of advocacy by the parents group, and so now many of the 81, not all of them, are actually tested if you tick the right box when you go in for your pre-partnership genetic testing. Would I say that the Israeli rabbinate, which is the service that marries probably 80% of the Jewish population in Israel now advocates for it? Absolutely not. But they have their own, data-related issues. But that having been said, here's a nationalized healthcare service that did recognize, because of real lobbying by parents of children that were unfortunately affected clinically very late in their course.
tie-in with IBS?
Sorry, tie-in with what?
IBS?
Can you hand this to her?
Irritable bowel disease?
Yeah.
No, it was just
It's
inflammatory bowel disease. No, it's just that they had done this large screen of people who did or didn't have that, and a lot of them were Jewish because it's a Jewish problem. So there were a lot of Ashkenazis in that screen, but no, there's no connection whatsoever. I'm sorry. Robin.
Oh, here, Robin.
So this question first is I have two questions. One is for Sue. How does it feel to have written a book which is about a disease and negative, which, about death, a very, very negative topic we all have to deal with, but that such genetic research has actually proven that we are an ethno-religious culture, even so we have a disease, but the benefit to it is that we now have a genetic Jacob's ladder that is reaching back for thousands of years and is basically proving that us as Jews, everything happened. That's my first question. So how do you feel about that?
I'm not sure I understood the question.
The question
Robin.
is, very specifically, we are talking about death. We are talking about a negativity, a negative thing. It could be viewed as that we Jews are deficient. But if we look at it a different way, that our genetic line stretches back thousands of years, and books like these and medical science has actually proven without a shadow of a doubt that what we see, what we study every week in the Torah, it reaches all the way back. How does it feel? Does it feel momentous?
I am very happy to have written this book and for all of the many people that helped me do it. And I feel close to Judaism. I also like to call this book a love story to my family. So a lot of it is about my family and how they responded to life in general and this particular disease thrown at them. And we, as a family all the way back, used some of our tradition, Jewish tradition, to deal with that, and I am very proud of that.
Okay,
Thank you.
The second question is, because of the recent data breaches into genetic databases, the hackings and so forth, what steps should be taken to protect our genetic data when we do get these tests?
But I do genealogy. The data breach at 23andMe was emails. They did not get your DNA when that hack. It was looking at emails, who you were, whatever. It was not genetic. That's all I have to say.
So, but what steps are being taken to support?
Yeah, I'm sorry, that I don't know. That's outside of my.
And I can say that health systems everywhere are doing everything they can, I think, within a reasonable cost to try to build defenses against hackers. But the hackers are always one step ahead, it seems, and that's a problem. What they're really going after are social security numbers, date of birth, things that they can then monetize very, very quickly. I don't think they can monetize genetic data quickly, even if they got access to it. And they hold health systems hostage for a fee, and for millions of dollars. It's a real, cybersecurity in healthcare is a huge issue right now, and it's costing all of us in this room.
Does anybody else have questions?
Also, kudos to you, Sue, that you only mentioned it to your children once, because as a Jewish mother of young adults, an expert in young adult medicine, not easy, I'm sure.
You know, you quickly mentioned canavans. I think you mentioned canavans, and you didn't mention in the book, at least as far as I have reached. I had 2 cousins who died of canavans, and no one knew about it. It was like, huh? Tay-Sachs was known, canavans wasn't. I'm going to let you answer what canavans is.
I just know it's a Jewish Ashkenazi gene, recessive.
And is someone else answering?
Do you want me to, can I say it really quick before you, or do you want to finish?
I just wanted to say one thing. I was lucky because my mother wasn't part of this family. She was an adoptee. But they went through genetic testing, every single solitary person in the family forever. I mean, it went generation to generation to generation. But what they learned is that the male and female both had to carry the disease. You sort of have mentioned that in your discussion, but it was probably above my head.
Well, no, so if you have a recessive mutation, both parents have to carry it, and then 1 in 4 of the children will get it from both parents. The disease that I'm talking about is dominant. Only one parent has to get it, and half of those children will get it from that parent. And indeed, part of, I spoke with Dor Vashem, I think it is, this wonderful organization that was put together by a man whose child died of Tay-Sachs, and they have this fantastic system among the Orthodox where you get a number when you're born, and then they match you up if you're going out with somebody, and they say, nope, that's not a match, and so you stop going out together. Well, I said, you've got all these people, you're testing their DNA, can you just test them for this one little mutation? Now, DNA sequencing is cheap. When I called them, it wasn't cheap. We know it, it's a PCR, you could just do it real cheap, just sequence it. Oh, they would talk to me for hours, oh, they were so sorry, and the baby died, but they wouldn't do it. They wouldn't consider it, because they want babies. They don't want to tell somebody that you might have a defect. Maybe they won't marry you. That's just not their approach. They're interested.
The rabbinic. She's talking about.
Dor Vashem. I can't tell about anybody else. It was the Orthodox people in this particular genetic group. Other Orthodox may be different, but this is the way this their goal was carrier screening for things that are recessive. You're perfectly fine. The boy you want to marry is perfectly fine, but the 2 of you are not a match. Find somebody else. That's okay. You can find somebody else. There's plenty of fish in the sea, but you're still marriageable. If you discover that he has a dominant mutation, he might not be marriageable anymore in that community, and they don't want any part of that.
So I just want to reflect back to the canavans and Tay-Sachs, and I don't know if everybody went through this, but we definitely did when we got married, is that there's these neurological gene mutation precursors that can be identified as a recessive gene. And so, as Sue was just saying, if you have 2 recessive genes, then you can't marry. You can marry, you just can't have kids. The odds of your children having this disease are of great risk. And so they recommend that you don't have children or you don't get married.
Or you do in vitro, that's what
or you do in vitro. Okay, so look at modern technology, right? I mean, the advancement of medicine through in vitro. So the other thing I do want to say, I have a little bit of knowledge on genes, which is really dangerous, I'll tell you that, because I'm actually a 2-time breast cancer survivor, and I do not have the BRCA gene mutation. I think it's really important when we talk about these conversations that we call them gene mutations. I like the dominant versus the recessive, all of that, but it's not, and so like this is when you're talking about it, there was something in the title about an Ashkenazi mutation. To me, that just sounds like we're all like monsters and we have these major mutations and we're gonna come out looking really weird. So I just wanna make sure that as we're discussing things that we all have these genes, right? We all have certain things within our bodies, and it's whether or not, like Sue was talking about the proteins, whether or not they can autocorrect themselves or whether they're being stopped by other parts of our body's an amazing machine. So it's all about the inside of our body and our DNA, right? Like we have our genetic DNA, but then each one of our cells has its own nucleus of a DNA, right? So there's so many levels and layers that we need to think about and understand. And I mean, thank you both so much for explaining it in terminology and words that we could actually digest and be able to hopefully have conversations with our families about and be able to educate others. My brother-in-law just had a major heart surgery in the Bay Area, and I'm suddenly like, oh my gosh, was this something that we should have thought about while he was going through this? I don't know exactly what his diagnosis was, so I just tagged my husband and, is this something that they mentioned while he was getting his diagnosis?
I do want to pick up on your thing about mutation, because that was one of the things that one of the many wonderful people who read my book and gave me criticisms, one of the genetic counselors pointed out that they don't use the word mutation anymore. That mutation is a bad word, but I'm old, I couldn't get used to that. That the word now is variant. That you have millions of different variants. Some of them are good, some of them are bad, some of them are of unknown significance. But I talk about that in the introduction, and then I go ahead and say I'm going to use the word mutant, because to me that's clearer that a mutant is something, a mutation is something that we're talking about here that is a variant of unknown, a variant of pathogenicity. It's a bad one. Okay.
I was just curious.
Oh, and then we'll pass to you next if you don't mind. Sorry, thank you. So I'm gonna ask just like a really base level question. Like, are we gonna find out someday that what diet we maintain and exercise, how much sleep we get, is all of that gonna be it doesn't really matter, let's do your genetic sequencing? Or does your lifestyle affect the expression of these variants?
I don't have a crystal ball there, but I'm pretty sure it's a lot of things. So you can have a mutation and it not have an effect. So many things can cause. I'm sure exercise is good. Don't worry about it. You're doing the right thing. I'll stick my leg.
Reminds me of a great line, a story that George Burns used to tell. And he performed until he was almost 100. And he would say, people come up to me and they say, George, you smoke too much. And George, you drink too much. And George, you hang around the young women too much. George, what does your doctor say? And I say, my doctor? He's dead.
So let this be the last question. Okay, we have one more.
Real quickly. Does junk DNA have any effect on these variants in your research?
So there's a lot of extra DNA before and after the stuff that codes for the protein, and there's a lot of stuff in the middle of the protein that we call introns. And it turns out that the mutation in my family is in an intron, but we don't consider it part of junk DNA because it's one base pair away. So they sequence things that are in introns that are right at the borderline. There's a lot we don't know about junk DNA, all this extra DNA and the effects it may have. The other thing we don't know that I haven't addressed at all is that not every disease is caused by, not every heritable disease is caused by a variant, a pathological variant in one gene. Sometimes it's caused by a whole variety of genes, many, many genes. And, there are programs where we're trying to understand that. But we do know something about 81 genes that are caused by variants that can be pathological in at least those 81 that we largely believe can be actionable. They think there's 7,000 genes that individually will cause diseases. We're not there yet. And then there's multiple genes that can cause mutations.
So my question is, I think about how, in a general sense, as human beings, we know how fragile life is, how vulnerable we are. Maybe Jews have an extra dose of that. My question is, in your research and your, kind of appreciating this issue in your family and in others, do you feel like knowing these sort of specific scientific, having this information that really does point to very specific vulnerabilities and fragilities in life, does it change how a person lives life in the sense of life being more sacred, values becoming more important? I'm curious if you have thoughts about, we all know this in a general sense, and then there are these very specific pathways revealed that put you at extra risk. What do you think about that?
I think we're all at risk, and of course, when we first learn something, we try to live every day and love each day more for a while. I just want to quote my father. He didn't know he had a mutation. He had no idea there was a mutation. He knew his father died in his 40s. He knew he had a brother who died at age 4. He served in the Army. And he had a colleague who died at age 50 when he was a young man doing, helping out teachers. So I forget what they call it, but he was a teacher helper. And when the 50-year-old died, he said, and it touches me because my son turned 50 yesterday, he said, well, at least he lived a good life because his father died when he was 40. And of course, everybody was pretty upset with him. Well, my dad was the most loving and well-liked person in the world. He wasn't used to everybody being angry with him, so he was pretty upset about this. When he turned 50 at the Passover Seder, he hits the wine glass and he says, now I can say it. My bags are packed. I'm ready to go. I've had my children. I was still in high school, but they don't need me anymore. I have a wonderful wife. I had a good career, but I'm ready to go. I'm thankful for these 50 years, and everything else is gravy.
Wow, beautiful. So I think that's a beautiful question or response to end on.
Thank you. Thistles and Nightshade has been kind enough to come by with books for sale. I also have pictures of the family, some reviews I was proud of that I posted over there, and then J-Screen, the picture genetics, and then this place called Connect My Variant that is a nonprofit, and I have their postcards. If you have a genetic variant, pathological variant in your family that causes disease, and you are interested in finding and warning other members of your family, even some that are not known to you, they will provide genealogists for free and help you do that if you register. So there's a postcard there from Connect My Variant, and please look through the information. I also have the saliva kit thing you can look at. You can see what it's like to,
It's very easy.
don't try it out, but you can read about it and look at it and see what it's like what they're asking you to do. It's not expensive, it's not invasive. It might make you worry. Try not to worry. Okay.
Well, thank you both so much. Again, thank you to Temple Emmanuel for hosting, for Sue for putting it together, and for Temple Sinai and Jewish Nevada for helping host it. So have a great afternoon, everybody. Oh, wait, sorry.
Okay, I do have one embarrassing more request. My publisher has said that I'm supposed to have 50 reviews on Amazon, and I have 12. So if you read the book, and if you're comfortable, please think about writing. It could be 1 sentence, 2 sentences, some little review on Amazon. Thank you so much for considering it.
I'd like to get to know you.